Okay, so in this video clip, I'm going to take a look here at the top skills for data analysts, and this has been developed by the outline here of the skills and so on has been developed by Scott W. O'Connor, published January 2020, so not too dated. And in part, the idea here is to promote some of the graduate programs of Northeastern University, quite a well-established university, long history, also significant research institution, and its recruitment onto even undergraduate programs would be quite selective. The key skills he identifies here are structured query language, so SQL, Microsoft Excel, critical thinking, R or Python-Statistical Programming, data visualization, presentation skills, and machine learning. And it is a nice portfolio that he puts together. It seems to balance quite a bit the technical, more engineered type solutions in data analysis, and it marries that or fuses that with the more critical thinking. How do we weigh up? How do we communicate out? How do we disseminate? How do we explain to our peers what's embedded in the data? And again, I think the balance here is correct. Structured query languages, that is a kind of one of the key skills in data analysis. It's also worth pointing out that many of the objectives, many of the tasks that we try to accomplish using SQL can be achieved in both R and Python. So for instance, in the as part of the R packages, right, the R portfolio, we have tidyverse, which is a relatively new series of packages that have been developed in conjunction with R Studio. And the tidyverse suite is made up of, in part, the ggplots and dplyr and so on. And many of the very standard things that you would try to accomplish in SQL can be equally accomplished with similar level of efficiency and intuition as you'll get in SQL. So dplyr, for instance, which is a grammar for data manipulation, right? You can execute this in RStudio or Google Colab. Runs on a number of platforms, but the basic tasks of performing queries on your data can be performed either in dplyr or even in the pandas library, Python library. So SQL, structured query language, is a ubiquitous industry standard database language and is possibly the most important skill for data analysts to know. The language is often thought of as being graduated versions of Excel. It is able to handle large data sets that Excel simply can't. So again, if you scale up and you move outside the visual limits or boundaries that we observe in Excel, SQL is a very natural place to execute many of the routine search and queries that you typically would have when you're trying to work with larger data sets or larger databases. Again, I would say the pandas library or dplyr would, from Python, pandas, can perform many of those tasks. So often there's a debate about which one. This is an article from Medium, and it's from May 29th, 2021. And again, they compare a little bit the virtues of both pandas and SQL. Pandas is used in Python environments, so like Anaconda or Google Colab or Spider. Here they look at the different treatments, how the pandas or SQL could be applied to interrogate a data set. And again, there's some interesting recommendations. I would encourage people to read that. Might be useful to go through here for a moment. The conclusion: SQL is more efficient in querying data, but has less functions, whereas in the pandas, there might be lags for large volumes of data, but it has more functions which enable us to manipulate data in an effective way. Python has also various data visualization libraries like matplotlib, seaborn, plotly, altair, etc., which helps us to visualize and hence helps us to analyze data more effectively. So again, SQL very good, quite efficient. Python, probably a more expensive library of search terms to parse through your data. Probably you can interrogate your data in using more rich queries, but also Python opens up easy integration into visualization, so matplotlib, seaborn, etc. SQL, of course, you can use SQL combined with Tableau, and that could be a solution where you get the best of both worlds, and where you can run SQL queries in the Tableau environment and get the rich visualizations that Tableau offers as well. So that's also a possibility. Also the ggplots deployer and ggplot2 from tidyverse, it's also a very strong package, and it's extremely good at providing very strong visualizations. Graphic capability is very sophisticated, and you can, with a simple grammar, create very nuanced graphing and visualizations, and also very good use and organization of space in the ggplot2. So when considering which of the data skills to develop SQL in that same space here, you could use R in combination with tidyverse, or use Python in combination with the pandas, where pandas is fused in with matplotlib, seaborn, altair, etc., plotly. Okay, so also Scott recommends Microsoft Excel. When you think of Excel, the first thing that comes to mind, likely a spreadsheet. But he's also saying here, look, you can automate quite a bit of what you do in Excel, the macros and VBA environment. And again, Excel is typically the workhorse that most people would use on a routine basis if they're involved in data analysis. One of the downsides with Excel is that when the data set scales up and you are trying to visualize on the spreadsheet environment, your data just becomes overwhelming, and then the SQL and or tidyverse or language base or Python, pandas, and the graphing capability built into Python, then that these other technologies come into their own, very, very important. Critical thinking is something more on the other side of the spectrum in terms of going from very technical programming to communicating, understanding, posing the right questions. Critical thinking is also very important in terms of any data analytical framework. And using data to find answers to your question means figuring out what the question is in the first place. That's something that probably we don't generally give enough weight to, but asking the right question is important. So critical thinking is important, being a little bit strategic in the way you approach data problems. And sometimes simple questions can be more revealing than more complex questions, and a series of simple questions provide ample nuance to address any set of ideas, or to try to understand what's happening in terms of trends in your data. In addition to that, data visualization would be important. There is quite a bit of data visualization in Excel. Excel has a suite of graphing capability that's very, very strong. But again, when we look at ggplot graphing capability, it's really excellent. And then the Seaborn, Matplotlib, Plotly out there also give a very useful portfolio of tools available in the Python environment. If you're doing deeper analysis, maybe there is some statistical modeling that you would like to be able to handle, and that might require some coding. So again, sometimes the discussion comes up, what about SPSS, SAS, compared to R, Python? More and more, there's a kind of increasing emphasis on Python and R, in part because it's coming from computer engineering typesetting, where Python is something that we can use in a general programming type. If you want to build an application, you could do it in Python. If we look at the TOB ranking, one of the very striking things about these programming languages is the extent to which in recent years Python has come to dominate. So if we look at the ranking of programming languages, Python is there, very, very prominent. You'll also find R, it's a little bit further down, but R is not a general programming language, but it's mainly used for data analysis. But still, you can write functions in R, you can write functions in Python. When you go to look for SAS here and these others, it's not really, probably doesn't fit into the same type of milieu. So one explanation why Python and perhaps R have become popular, obviously they're data driven, but also because the other contenders here in the space are sort of limited to statistical analysis. So SAS is sort of limited to a particular type of statistical analysis, likewise SPSS, whereas R and Python have more general applicability. Data visualization, the different libraries like ggplot2 for or tidyverse, and Seaborn, Matplotlib, Altair, Plotly for Python are really provide rich mosaics and very nuanced type graphing capability. Relatively newer visualization tool extensively used now, or increasingly used in industry is Tableau. That's what we're taking to look at, and you can get a nice combination between Tableau and SQL. So if you're performing SQL queries, you can fuse that in with Tableau visualization, and that's something that's worth considering. Now, Tableau is not completely free, whereas R Studio, Python, Google Colab, the Spider, the Anacondas, the platforms that we typically use to run R and Python, they're basically free to use. SPSS normally involves a subscription. Likewise, SAS also involves a subscription. So again, as a data analyst, if you're at that early stage where you're trying to learn, there is an advantage that these resources are available for free. As always, as a data analyst, presentation skills, I would say, have to be considered really a top priority. If you understand the data, great, but trying to communicate that is going to be important, and then the presentation skills makes that task or facilitates you achieving your objectives more easily if you can present. So presenting doesn't always come naturally to everyone. That's okay. Even seasoned presenters will feel their nerves get the best of them at times. But still being able to present your information, what you've gleaned from the data, always important. And then as increasingly, machine learning has become important in recent years. Artificial intelligence, predictive analytics, these are the hot topics. And again, when we go back to look at of this other more technical side of the skills in terms of what we acquire, both R and Python have dedicated libraries. So Caret for R and for Python, sklearn would be quite well-known industry standard libraries that are heavily used for running. So we might just bring that up. sklearn in Python, for instance, would be typically a package that is used for machine learning or modeling, right? And when we talk about machine learning, we're talking about maybe issues dealing with classification. So if you want to predict, or you want in terms of maybe diagnostics, if there are a certain number of attributes and you want to predict if a particular diagnosis was warranted, machine learning would be useful for that, for predicting the future, for regression model, for ordinary least squares, if you're predicting house prices, perhaps based on attributes of housing stock, then these type of techniques, SVR, nearest neighbors, random forests, would be important. Clustering and so on, model selection, dimensionality, test and train your data set. All these have been automated in the in the sklearn library. Likewise, for R, you have Caret, and again, there's a similar type of streamlining of that in the R package, and probably again at a very high standard, right? Worth considering as you develop your data analytical skills. Okay, so that's a neat summary then. I would say, yes, SQL, very important, or could use dplyr, package other data transformation techniques available in the tidyverse suite, or for Python, the pandas. Data visualization, always important, being able to graph, very significant. The starting point for me, for any data analyst, is to be able to master Excel. So having an understanding of data in a tabular form, in a spreadsheet format, very, very important. Being able to automate that using VBA, I would say, is very important. Being able to apply macros, that would be a technical set of techniques that I think would be hugely invaluable for data analysts. SQL, then it depends. If you already are using R or Python, there are ready-made inbuilt libraries that perform much of what SQL does. So it's again, if you were a complete data analyst with a fully rounded set of skills, SQL will be important. But just simply to accomplish the tasks that are set out by SQL, you'll get those in R and Python using different libraries. It all depends on what weighting you want to put on each of these and what your peers are using in whatever environment you're working in. If your peers are using overwhelmingly, if they're really heavily reliant on SQL, then that perhaps suggests you might need to learn SQL as well. But it is an industry standard. Data visualization, important. Presentation skills, important. Machine learning, increasingly important, particularly in the area of diagnostics or predicting consumer behavior. Very, very important. Quite technical, but has been streamlined in Python libraries like sklearn and Caret for R. And being able to present your data, being able to disseminate, being able to communicate out the information that you glean from your data is as important as being able to interrogate your data in the first place. Okay, so that's a summary, and hopefully that has been of some use to people trying to figure out what are the key skills, top skills for data analysis.